so much I would like to do. I'm trying to decide. Um, would you folks be interested in a class called
Pastor Jim, we have friends coming that I haven't seen for years, and they're coming from Sandpoint graduation.
So we should wait?
No, you want to, because we're going to go with them now.
We're recording it.
We're live streaming it.
You can see them.
Would you folks would you folks be interested in a class I call Nuclear Physics for Dummies? It's not that you're dummies, but I try to make it simple enough for dummies. You
I do
understand?
history for dummies. I do geography for dummies.
In order to understand,
Particle physics.
yeah. Can we get this on the screen yet?
Oh,
It's plugged in, so I suppose it should work.
Okay, there it is.
Thank you.
He needs the microphone.
There we go.
It's right there, right,
I don't think I need the microphone, or do you need it
you
for the
need the microphone.
live stream? Okay.
in order to record it.
Too bad you don't have the earphone thing, then you wouldn't have to hold that.
It doesn't work on my ear. My ear is famous for not holding these things. Of course, everybody has that problem. So they make new ones now that connect to both sides.
Hey, you talk about ear problems.
Yeah,
Count your blessings.
yeah, I do. Is this on? Hello, test?
One thing you want to make sure you don't walk too far in front of the speakers and
Okay,
get feedback.
I get that. I understand that.
Robert Gentry still alive?
No, he passed away about, I'd say, 3 or 4 years ago. Okay, I still don't hear this, so I'm happy to start. But,
Is the switch on?
oh, no wonder. The problem is I need both hands, but we'll try that. Let's pray before we start, shall we? Father in heaven, we are absolutely in awe, even though we only grasp a tiny portion of the wonderful power and love that you have for the universe. But bless us as we struggle with some challenging concepts, I pray, in Jesus' name. Amen. So in order to understand Gentry's work, I'm going to use some, boy, I need 2 hands, but we'll make it work. We're going to let, I'm going to say pink, even though they're, anyway, I'm going to let this pink ball, I'm going to call it pink because pink starts with a P, and the name of this particle in the nucleus is a proton. Most of you know that word. Most of you probably know, and please learn if you didn't, that all atoms have proton or protons, if you will, in the middle, and then they have these things we call electrons. This is a simpler explanation, flying around them. Don't you kind of all know about that? And these things are electrically charged. This has a charge of +1, we say, and this has a charge of -1. And then there are these things called neutrons. Guess what charge they have? Neutral. You know, if that was standing right here and it could kind of pick me up, I do need both hands, if possible. And really, the people in here can hear me, but it's the live stream that needs the mic, so thank you for that very much. A little bit down. Were you going to go down a bit? Toward me? Okay, all right. actually like it down about there, if you wouldn't mind. It'll pick me up a distance away there. So, you can think of the neutron, see if this makes sense. Maybe I want to tell you one more thing. We say that a neutron weighs 1. And in that weight, this electron is 1/2000th. So it's kind of too big, but I just bought some golf balls, right? Or some practice. And by the way, hydrogen, the element or the chemical hydrogen, has 1 proton normally and 1 electron. And if you made, and you understand these things are very, very tiny, very, very tiny. But if you scaled that proton up to this size, this would be out there 6 miles away. And this is essentially the case for all elements. They are 99.99, and you have to write 13 nines, 99.99, 13 times empty space. Everything is mostly empty space. When you hit something, you're hitting electrons that are flying out here in various orbits, and it's mostly space. So when your kids don't understand something and you feel like saying, you are empty-headed, you are correct in your... Now, I'm going to try to start this simply. I'm going to show you the elements. And if you took hydrogen, carbon, and nitrogen, and oxygen, and found out how much of that was in you and me, you would get 96% of our weight. We are mostly made of those 4 elements. Are you all with me on this? Carbohydrates, fats, proteins are all made, mostly all of that. And there's something interesting. The way that the scientists have decided to draw these charts is, this is the number of pinks in the upper left-hand corner. That's the number of protons. So over here at carbon, you may not be able to read that. Can you see that number right there?
6.
It's a 6, and and nitrogen is 7, and oxygen is 8. And that's going to be true for all the elements. In other words, it is the number of these in the nucleus that determines what the stuff is. If there's one of these in the nucleus, what is this? Hydrogen. If there's 2 of them in there, 2 of these, they're almost always balanced. This is -1, this is +1, correct? So if the hydrogen is like this, then it's neutral when you back away from it a little bit, right? If you were up close like this, you'd feel the electric charge. But you understand what I'm saying? They're balanced. Now, you can ionize an atom, but that's not the natural state. The natural state is that there's the same number of negatives as there are positives. And so if I put, notice that helium over here, how many pinks are in there?
2.
You can see the 2 okay? But it weighs 4. So if you look over here at this one, see where it says atomic weight? Forget the little number out at the end. The proton is 1, and so the total weight is 1 plus a little bit of an electron. Very tiny, tiny weight in comparison. Helium has 2 pinks, and because it weighs 4, how did that happen? It happens because there's 2 neutrons there. And here's what's going on. You all know that like charges, don't worry about that. What do like charges do? They push. Stay with me, everybody, because in a minute you're going to say, oh, that went over my head, unless you stay with me. Like charges push. And in the nucleus, the push is very, very strong because they're so close to each other. And in order to keep them from flying apart, the Creator has put neutrons in there, and then the nucleus is stable. Y'all with me on that? It won't fly apart. By the way, when they do fly apart, we call that nuclear radiation. And most of you are familiar with radon gas. You know that it can kill people with lung cancer. I'll talk about that in a few minutes because stuff is flying out of it. And those things, tiny as they are, they can destroy tissue. So that is a helium nucleus. Are y'all with me on that? And how many electrons would there be flying around out here? Two, to balance these two pluses, right? Now you can think of the neutron as being a plus and a minus hooked together. And that actually happens. There are times when these neutrons send out an electron and then suddenly it's a proton. Does that make sense? No. I'll say it again. Follow me carefully. Do you understand that this has a charge of +1? Do you understand this has a charge of neutral? Because there's a +1 in it and an electron in it as well. You can think of it like that. So, and the electron is very tiny, right? Super tiny, so it doesn't change the size of this and hardly the mass at all. Are y'all with me on that? So it turns out that in nature, it's often the case that this thing will shoot out an electron, so then what does it become? A proton. Shall I say that one more time? You understand these are just plain protons. This thing turns out to be a proton with an electron in it. And there are times when that electron will fly out, changing this into what? A proton. I'll show you that. It's part of Gentry's thing, and so that's kind of an important idea. But anyway, it is the number of protons in the nucleus that determine what the stuff is. I won't try to do this with my hand, but if I was to make carbon, I would need how many more protons in here? Four more. And because the weight is 12, subtract the 6 from the 12, how many neutrons would be here? 6. So in the chemical, in the table of elements, that's the weight. That's the atomic number. That's the number of pinks. And this is the weight. And if you subtract that from this, you'll know how many neutrons are in there. Following me? It's all new stuff to you, but I think you can follow it if you keep working with me on it. So just for fun, let's do another one. Let's take oxygen. How many protons are in it? 8. It's called the atomic number, by the way. And what's the total weight? 16. So subtract 8. Is it 16? All right. So there's going to be 8 neutrons in there. And here's the problem. The more of these pinks you get in there, the more you need these neutrons to keep it from flying apart. That's the function of the neutrons. If it was just pinks in there, what would they do? They would fly apart, and no element would be stable. It would become something else. And so you get, and when people see this, they go crazy. They're scared. No, don't do that. Here's uranium. How many protons in there?
92.
Correct. Since the total weight is 238, you subtract 92 from 238, what do you get? 146, right? 146 whites just to keep those 98 ones from flying out of there. This is amazing stuff, how God has created all of this. Now, at the risk, let me say this much. I was going to say at the risk of going too fast. So this is a helium nucleus. Are you with me? 2 protons, 2 neutrons, and it turns out that hydrogen, normally is like this. Are y'all with me on that? 1. Every once in a while, a tiny percentage of hydrogens are like this. But because it's still one pink one, it's still what? Hydrogen. Remember, the number of pink ones determine what it is. And this is neutral, so it's fine. 1 electron, 1 proton, but it weighs twice as much as it normally does because the neutron's there. And that's a tiny percentage, but it's true. Right in this room, there are hydrogen atoms that have, just like this, but rarely, once in a while, like this. Are y'all with me on this? Now watch this interesting thing. So this has a certain weight. And under the right conditions, and I'll explain that in a minute, you can get this hydrogen to hook up with this one. Follow me carefully. The weight is now less than it was before. The weight of these two together is less than the weight of them apart, added up. Got that?
You still have the electron out there?
Yeah, in this case, when they come together, there's now 2 electrons. Good question. What do you suppose happens? Here you have a weight of 4, and now, let's say, this is too much, but now let's say the weight is now 3.5. What do you suppose happens with that other half? Follow me carefully. It becomes energy. In the sun, if there's high enough temperature and high enough pressure, these kinds of hydrogens can be fused, and the decrease in weight is released as energy. Got that?
Yeah.
That's what makes the sun hot.
So does that mean an electron flew out?
No, the electron is not an issue there because this is so much heavier. But when these two things, under enough pressure and temperature, are forced to become one atom, which is now helium, right?
Right.
That's what makes a hydrogen bomb. Have you ever heard of a hydrogen bomb? In order to make a hydrogen bomb, you have to light off an atom bomb to get enough pressure and temperature to make this happen. Got it?
Yeah.
Isn't that cool? And that's what makes the sun hot. Scientists discovered helium first in the sun before they found it on the earth. You say, how did they go to the sun? You just look at the color of the light and you can tell what's there. Not the color you see with your eye, but with a special instrument that breaks the colors up into the whole spectrum, right? And they saw this line. We don't know what that is. It turned out it was helium. And that's when they understood that the reaction taking place in the sun was combining 2 hydrogens that had neutrons. That will not work with just 2 plain hydrogens. They've got to be the kind, and a certain percentage, even in our own atmosphere, a certain percentage, tiny percentage, are like that. And what scientists do for a hydrogen bomb is they filter out these. Y'all with me? And they don't want those. I'm talking of hydrogen, right? They filter out the ones that are like this till they get enough of them in a cage, if you will, and then they light off an atom bomb, like Hiroshima, that gives enough pressure and temperature to make those babies come together, and they just made a what? Hydrogen bomb. But I hope some of you are already, the eyes are already closing, and I'm really sorry. I try to be more interesting than that. But the point, folks, is that when you combine nuclei, the whole thing weighs less than it did before. And that change in mass becomes what?
Energy.
Energy. Hydrogen bomb. Crazy.
Well, then what's splitting an atom?
Splitting an atom, let's say if you can imagine this, I can't do it with my hands. Let's come down here to, let's say, it doesn't matter, but let's get an atom with a number of these pinks, and there'll be a bunch of neutrons holding it together. You can shoot a neutron into here and cause it to fracture into other materials. So that's splitting the atom.
But I thought that was the bomb.
Yeah, they talk like that, but what makes the atom bomb, now I was describing a hydrogen bomb, which is much stronger than an atom bomb, but what makes the atom bomb is you have this uranium, and U-238, look how many protons, 92, I did it before in my head, 138 plus 6, 138 plus 8, so it would be 144. 144 neutrons are needed to hold all 92 of these protons from firing out. But once in a while, a neutron comes sailing out of there. And if it goes to another uranium atom, it will cause the uranium atom to just kind of break in half. And guess what? A bunch of energy is released.
Oh, that's the
And then when that one split, it sends out some neutrons and splits some more, and you get what we call a chain reaction. And you know this whole thing happens within 100th of a second, and you get all this energy released, which we call an atom bomb. One uranium, if you get the radioactive uranium. Now what makes something radioactive is that, oh, I'm so sorry. These things tend to fly out once in a while at random. And let me show you that in what we call the next slide. I know this is heavy stuff, folks, but in a way it's simple if you'll work hard with me. This is the decay. We call it decay because stuff flies out, and I'll explain exactly what I mean. The decay of uranium, the one we were just looking at. The first thing that happens to a uranium is, and I'm sorry that scientists do this, they got to name everything. So that alpha particle, I think I have it on here, is actually a helium nucleus. So we're back to what I talked about a minute ago, if I can keep my stuff together here. What did I tell you that was? A helium nucleus, right? One of those comes flying out of the uranium. That's what this arrow means, and it tells you what comes flying out. Now stay with me. If this thing weighed 238 and 4 pieces came flying out, what does it now weigh?
234.
And so it makes what? Now follow me closely. 4 units of weight came out, but 2 of them were protons. Is that correct? So that changes what it is from being uranium. Notice this. Here's uranium at 238, and if you go down to 234, without my glasses, where is it at? Thorium.
TH.
There it is, yeah. You see how this now weighs 232? And it's 90 reds or 90 pinks instead of 92. Are y'all with me on this? Because this thing flew out of it. Are y'all there? It lost 2 pinks, but it also lost 2 more weights. So the weight is now 234 instead of 238, correct? And the atomic number, if you will, is now instead of 92, it's 90. So would this make sense to you then? Thorium. And actually, I put these on here. Where did they go? There it is. So thorium has 90 pinks. You see it there? Because this thing came flying out, correct? This is just what nature does. And it weighs 4 less, but the pinks are 2 less. Y'all with me? And if I say it again, it's the number of pinks that makes it what it is. It doesn't matter how many of these guys are around. It's the number of pinks or protons. Now notice this interesting thing. If you had a pound of uranium and you let it decay to thorium, it would take 4.5 billion years before half of that uranium had become thorium. You know the term. That's the half-life. Are y'all with me on that? You've heard that term.
How many years?
4.5 billion. That's 10 to the 9th. Do you see the 9 up there? And if you don't know what 10 to the 9th means, you probably do. It means 1 with 9 zeros, which is a billion. So that has a long half-life, doesn't it? Now, once it's thorium, what comes out of thorium? I didn't tell you. What is beta stand for in the physics world? An electron. Okay, watch this now. This is pretty interesting. I know this is hard, folks, but in a way it is so simple. The problem is it's just new. Remember I told you that this guy is really an electron plus a proton, correct? So when an electron comes flying out of thorium, what is suddenly left behind? Got it? Shall I do it again? This is made up, this is simplified, but it's reality. It's made up of an electron and a proton, and it's neutral, right? And when the electron comes flying out, what's left? Did that electron weigh hardly anything? No, it's just a tiny, tiny, tiny change in mass. So notice what happens then. The next element, instead of 90, now has another proton back in it. Because the electron, when it left the neutron, made a proton there. So the number of protons went up 1, but the weight went down. The weight stayed the same because the neutron stayed there now as a proton. So this is the decay chart for uranium. And the half-lives are given here. How long does it take for half of the thorium to disappear?
24 days.
Just a little less than a month. You following what I'm talking about? A month later, you'd have half of that. And a month later, half of that. You get the idea of half-life, right?
Would it weigh half as much?
It depends on what the decay is. If the decay is an electron, it weighs the same.
Oh.
Right? If the decay is an electron, it weighs the same still. Because this became an electron, and now, it was an electron and a proton. Electron leaves, now you got a proton left, right? So the weight's still the same. Got it? Because the electron is such a tiny, tiny, tiny fraction of the weight of one of these nuclear particles. You don't need to hear this, but I'm going to say it anyway. Even some professionals out there use the word nuclear. That is not correct. Nuclear. Who cares? President Bush, nuclear. Nuclear. Okay. Let's not take too much time, but the point is, these half-lives can be very short or very long. This one here is 2 times 10 to the 5th. That would be 200,000 years. And so forth. Here's one that is the one that he uses, polonium. It's a little longer, but it's still short enough. I'm talking about Bob Gentry now. Some of these, look at this one. What is 1.5 times 10 to the minus 4? That's 0.00014 seconds. So the half-life from polonium to lead is a tiny, tiny, tiny fraction of a second. So if you get any of this polonium made in nothing short, it's virtually all gone because the half-life is a fraction of a second. Y'all with me on that? And,
How do you know it exists?
well, that's a good question. But there are ways to detect these things, and one of them is what Bob Gentry did. Can you ask any questions about this where I have maybe confused you?
I have a question about the chart. Why is uranium listed as uranium-238 and also as uranium-234 in two different places?
A good question, because it's always the number of pinks that makes it uranium-238. I mean 92.
And so after it loses one from that one, it loses another one and makes it back into uranium again.
If you lose an electron out of this, if you use an electron out of this, suddenly you had an extra proton.
And you're back to 92.
You're back, exactly.
Okay.
Very good question, good observation. Anybody else?
So there's uranium-238 and uranium-234?
But their pinks are still 92 each.
Oh,
Remember, the weight difference is the neutron.
So that's obviously the same with the bismuth too?
Yes, same idea.
Okay.
And it's the number of, if you reduce the number of neutrons there, the thing becomes more unstable and more likely to fly apart. Right? What's your name, sweetheart? Topaz. Okay, I remember hearing that earlier. Anybody else?
so all the things that end in IUM, does that mean they're radioactive?
That's a question I have never thought of before, but all of these things are radioactive, and some of them don't end with IUM. So, but it's interesting that you observe several of those points. Can you throw it back to me, dear? Real hard. Throw it real hard. Oh, not quite hard enough. That's okay, leave it. I'll take care of it. So what Bob Gentry did, he found a way to look for polonium-214. And here's how he found it. In this picture here, he is showing you a photograph. You take a piece of granite and you slice it open and you put a microscope on it, and you see these tiny, tiny, tiny rings. Halos, if you wish. And what you actually have is a ball that when you slice it, you see the edge of the ball that looks like a ring. And what's making the ball is, at the center of this ball is a little bit of radioactive something, which means it's going to start shooting particles out, correct? And those particles travel a tiny distance in the stone and stop. And where they stop, it makes a mark. And there's hundreds of billions in one tiny, tiny, tiny spot. Atoms are so tiny, folks, it's unbelievable. So there's enough there, sending out these pieces that stop at a certain place that you can then cut it, and only with a microscope you can see these little tiny circles. Are y'all with me on that? And Bob found a way to tell which ring was created by which decay. Y'all with me on that?
But do decay
Here is the piece of radioactive material, and it makes 1, 2, 3 rings at least. Different decays at that same place. And remember, these particles, they're mostly alpha particles, travel a little distance and then stop, and they make a mark. And he was able to figure out which decay each ring was. And I don't really know the details of how he did that, even though we should have talked about it. And other people were aware of this phenomenon and had done some study on it as well. And I want you to see, can you see uranium-238, 234, thorium, radon, Rn, what's Rn? Polonium. He was able to figure out which rings were caused by which decay. Does that make sense?
Mm-hmm.
And It's such a powerful argument, folks, there is no way to refute it. The average scientist believes that the Earth started as molten and rocks congealed over time as the heat was released. But if that was the way that granite was formed, and that's what Bob studied, I'm sure other kinds of rocks were studied, you might find the same thing. But if something cooled over a long period of time, the rings that have the tiny, tiny half-lives would not be there. Are y'all with me on that? Because they're long ago gone before the thing made a rock. Got that? And you just can't get around that argument.
And what's the meaning to that?
That this rock had to be made instantaneously. Isn't that powerful?
Yeah.
It sends chills down my spine, frankly. God said it and it was done. And it what? Stood fast. And it was good. Now, I don't know how this happened. Bob was only there my freshman year, but by the time I was a senior, he was back as a guest speaker telling about his work. When I was a freshman, he had not yet started on this. And I was so excited. I went there. We had a great big, the big rotunda auditorium there at Walla Walla, if you've ever been there. And I just couldn't believe what was happening. My professors were kind of attacking him. And unfortunately, I've never talked to Bob about this. I should have, I suppose. He became defensive, and it kind of made it worse. And it just broke my heart, because Bob is such a great guy. Was. And so he even lost the confidence of the Adventist scientists, by and large. I'm sorry to say.
Did that ever come back?
Not to my knowledge.
And yet he was actually, they should have been all for him.
They should have been. So they're both at fault, aren't they? But the enemy of our souls loves to find cracks in our convictions, armor, whatever. And who of us doesn't have them? Correct? We all have our weaknesses. You don't need to know this. One of mine is impatience. And the other day I got impatient with our pastor's mother-in-law because she kept interrupting me. And I felt so bad. I called her up and apologized. And you know what she said? She said, it was partly my fault. I was being impatient with you too. And isn't that precious when people... So guess what? Our hearts are knit together now. And so the Lord uses our faults, actually, although there could be better ways, I'm sure, to still teach us and, if we're willing, to bring us together.
Robert Gentry had a son that was continuing on with his work.
I didn't know him as well as his dad, and I don't know as much about his work as I did about his dad's, but I've watched him a number of times on 3ABN and very pleased with his, interest in becoming a scientist like his father and carrying on with it. But this evidence is irrefutable. You cannot have those marks in that granite if the granite was formed by cooling.
Now is his accepted by other scientists?
I
As
don't
an
really,
atheist?
I'm ashamed of myself to say that I don't know. I never see it in the literature, and I do a fair amount of reading. I never see anybody bringing this up. And of course, Bob, you can sympathize with his being impatient about this whole thing because it's an airtight question. And Bob was a supreme scientist and took great care in what he did. But it still stands to show that when God said, let there be this or that, his own energy, folks, I hope you got this point. I just talked about the energy to form the earth, the energy to form all the stars. Are y'all with me on this? and the galaxies, which almost seem to be endless in number, all were created by his statement. Now, this is terribly important, but for what it's worth, my personal opinion is that God has not been sitting around for a few billion years and then suddenly made the whole universe. I think he's been creating stuff all along. When we get to heaven, he might even say, would you like to see me make a galaxy? Whoa, yes! I mean, why not?
Yeah.
And I think we're pretty clear that he's not going to be creating more beings. Otherwise, we'd have a risk. I think that the universe is going to be safe because of what happened here. You all know what I'm talking about, don't you? About the sin experiment, right? And when we get to heaven, we're probably going to say, oh, we didn't have a clue, did we? Even though we try to explain stuff. It's going to be so much fun to study. And you know what's happening to me these days? I shouldn't do this, but I joke and I say, my wife is getting older. As though I'm not. But I'm forgetting stuff. Do you guys, any of you guys know about that? Several of you know I was trying to come up with a name today and I couldn't come up with it when a few years ago, they're just there, you know, like that. So, but when we get to heaven, everything that we're taught we'll instantly understand and never forget. Won't that be amazing?
No comment.
And, well, I don't know, but I think that the universe operates like this. I'm not certain of that, but I think we'll find. You're number 2. Wasn't there a hand right here? But go ahead, since they did.
These are pictures taken from an electron microscope, or are these diagrams?
You can see this with a light microscope. These, yeah. In other words, that's enough magnification to see these rings.
What magnification?
Oh, I would guess on the order of 1 to 2,000, something like that, with a light microscope.
So you could buy a microscope and see that?
Yes, it takes a lot of work to get the slice to cut right through the source,
Oh,
right?
yeah.
So it may not be as easy as it looks from the surface.
But those are
Those are photographs.
Photographs.
Yeah. And nobody disagrees with Bob on which these lines were. Other people had seen some of that too. He's not the only one. But he was able to tell which line was which decay, and very, very interesting stuff. Yeah.
And that's explained in the book somewhat?
Not in much detail. Not in much detail. You know, I proofread the book for him, but it's been so many years ago that I'd have to, I have it in my library still, so. Now let me ask you if you would like to be interested in, there's another area I could treat here for a few minutes in terms of the age of the earth, which is fascinating. I also at times like to answer questions on physiology and health. I'll give you an example and you can vote. Should we do that or go on with something else? I guess I should stay near the microphone. And the results of this might step on somebody's toes, and I apologize in advance. But you know there's a big issue today about using a microwave or about Wi-Fi. Would you like to hear a short lecture on that question?
Yes.
And it is my field. Radiation is my field. I'm a nuclear physicist, so I speak with some authority. Not only that, but I've studied this stuff all my life, so all my adult life. So I'm going to take this with me because I've got to write on the board. And in order to do this, oh, I didn't have you vote. You want me to do that? How many say yes? Would you rather have me do something on the age of the earth, which maybe I'll do if you can stand staying? Okay. I want to stand where everybody can see this. And I need a board bigger, but we'll make it work. I'm going to talk to you something about a spectrum. Ooh, that one's not working. There we go. And this is a spectrum of electromagnetic radiation. Light is electromagnetic radiation. Heat that you feel from the stove if you're standing near it is electromagnetic radiation. Have you ever driven by a big bonfire in your car with the window up? And what do you feel as you drive by? You feel the heat. That is electromagnetic radiation. It's a kind of phenomenon that has an electric field and a magnetic field at the same time. That's why we call it EM, or electromagnetic radiation. And it comes at different wavelengths or frequencies. And down here are the long wavelengths, maybe thousands of miles long, the waves are. And somewhere up here, about here, is the visible spectrum from red to violet that your eyes can actually detect the radiation only at those frequencies. You all know about infrared. I'll mark it as IR. Are you aware of the fact that some creatures that God made, their eyes can detect radiations or wavelengths longer than ours? You can buy cameras, movie cameras, that you can flick a button, and if you're looking through it at night, you can see stuff because of the heat being radiated from the animal. You all with me on the idea? Please stop me, folks, if it's not clear, all right? Please, right? You're all familiar with ultraviolet radiation, which scientists have divided into 3 parts. A, you kind of know this, I think. B and C. Are you aware of that? Ultraviolet A is not damaging to tissue. Ultraviolet B is, but ozone up here, OZ for ozone, stops the ultraviolet radiation in that range. Actually, in this range too. And just to be clear, you understand that what this graph means is shorter and shorter and shorter and shorter and shorter and shorter wavelengths. Are y'all with me on that? They all travel at the same speed. And if you think about it, you'll understand this. If the wavelengths are shorter, then the frequency is higher, the number of troughs and peaks. So you can look at this as either increasing frequency or decreasing wavelength. Got it? Sort of? By the way, down here is where the ham radios operate. And pretty soon you get up here to, I'm leaving a lot out. You get up here to AM radio. Back in the days when there was a dial and a graph of the frequencies, what was the frequency at the low end and the high end of the old AM radio? Anybody remember?
550 and 1400.
Okay. 550. Sometimes I just write 1500 up here. And you know what those numbers mean? 500,000 cycles per second. That's a lot. And up to 1500. And scientists learned very quickly how to make a little electric device that would transmit music or sound at a certain frequency. And then put it up on a radio station, and you turn your dial and get that one, and you can listen to it. You all know, of course. Then you come to FM radio. Anybody remember what the 2 numbers are that span the FM band?
17.9 on the top end. No, 107.9 on the top end.
It's 88 to 108 is what I usually say. He said 107.9, but 80, you know what those numbers are? Millions of cycles per second. It's mind-boggling, isn't it? Why was FM radio so much nicer than AM radio? I'm going to tell you why. See if I can make it make sense. You understand that FM radio was nicer because we say the fidelity was better. And what we mean is the higher the frequency, the more information we can put on it. Information would be more frequencies to make it sound more like the real sound is. So this is true. The further you go up this spectrum, the more information can be packed. And if you go as far up as a light wave, you can put billions of times more information in a light wave than in an FM signal, because the frequency is so much higher. You got the idea? The higher the frequency, the more information you can put on it. That's why fiber optic cable is so far superior to sending signals, let's say, as microwaves. You know that these towers all around the place, those are microwave towers that used to be out there. Still there, some. You know what I'm talking about? And so they transmit a signal for 40, 50 miles or whatever. Way less information than a cable, whether it's underground or not, that's got little tiny plastic strings in there that you can put information using light waves. Put information into the light. So that's why fiber optic cable is such a big deal. Way better than transmitting information down here. Y'all with me on the idea? Pretty interesting stuff. So, and by the way, information is increasing as we travel in this direction along this spectrum. Y'all with me on that? And so is energy. Energy is increasing as you travel down here. So you can have radio waves from FM or AM pass through your body, and hardly any energy is absorbed. You could make an antenna that had enough radiation with a big, powerful transmitter and concentrated that maybe you'd feel some warmth or something. But it isn't until you get to ultraviolet B that there is enough energy in the wave to mutate the DNA. Got it? Follow this. All cancer, and there is absolutely no exception, is the result of mutations in the DNA. Some of those mutations are inherited. Some of them occur in real time. But there is no exception. It is DNA mutation that causes cancer. You all with me on that? I have a couple of lectures on that, just that one point. So, and I realize this may step on some of your toes, and I love you anyway, and I hope you love me anyway. Microwaves are about here. And 5G is about here. And the idea that those are just automatically bad for you is just plain false. Are y'all with me? That might step on your toe because you may have heard somebody. You know what my wife says about me? She says, people believe you because you sound like you know what you're talking about. Now, actually, I use that emphasis because it's so cute. She means well. She says, people believe you because you sound like you know what you're talking about. But I like to say it like I did, that you sound like you know what you're talking about. Anyway, so I apologize if you are, and I meet people sometimes that are angry when I explain this because they know they're right and they know that I'm wrong, you know.
I have to say this. The reason I even made that statement is that I admire that. I'm more the lacking the self-confidence when I speak. And I like it when someone speaks with authority.
Isn't she sweet?
So it describes,
Okay. I'll go some more, but I'm happy to take questions in the meantime.
So where does the myth of the microwave and the 5G are bad for you come from if it's really way down there on that,
Uninformed.
just being
Yeah. Now, there's another issue going on here, and it's a really important point, and you helped me bring it up, but I usually get to it anyway. There's this thing that physicists call intensity. And for example, let's say I have a little flashlight here, a little tiny flashlight that you use to whatever, and little tiny thing, and I shine it at you from 40 feet away, and it's kind of bright, but you know. But what if, but you can look at it. What if I made an array of 1,000 of them right here and shined it at you? It hasn't changed the wavelength at all. Are you all with me on this? But the intensity has been increased. And it depends on the tissue that's receiving the intensity, whether that might, one of the problems is you can create enough heat so that tissue is burned. The other issue is, because of certain physical characteristics, there might be some tissue that would absorb that particular frequency more readily and maybe create some heat or even some damage. So can you imagine, friends, how the average person on the street has virtually no clue what I'm talking about right now, right? And they will listen to somebody who sounds like they know what they're talking about and claims to have credentials, and they're absolutely convinced. And I'm not pushing this stuff. I just want people to be educated and make rational choices.
Following your example of a small flashlight and then 1,000 flashlights, can you relate that to 5G?
You could easily make a device that would transmit enough energy in a confined beam. Yes.
Are we experiencing that?
No, no. You guys, if you've been following this at all, know that the 5G antenna is about this long, and it's this long because that's about the wavelength of the energy. And it dissipates rapidly. Do I need to quit moving around like I am? That's why they have to have an antenna every 300 feet, because the energy is dissipated so quickly. And if that frequency was high enough to do damage, normally you're talking thermal damage. You'd start to feel some warmth, or maybe it got too hot or something. By the way, when the 3 young men were tossed into the fire in Daniel chapter 4, or is it 3, what happened to the soldiers that cast them in? They were slain, killed, because of the fire reaching out and licking at them? No. There was a huge in and updraft. What killed them? Infrared radiation. Are y'all with me on this? You know this, you've been at a campfire. The flame is going up, but you can only get so close before it's just too uncomfortable because of the intensity. So, go ahead.
Does the microwave change the consistency or the elements in the food itself?
Yeah, good question, and I'm coming there actually, so thank you for helping me remember that. One of the easiest ways to illustrate that is a study was done in the University of Nevada at Reno by a physician scientist who studied heating mother's milk for young women who either choose not to nurse or can't, and so they pump and the baby's fed that way. And there's something you may not know. In all mammals, why is that thing blinking? Okay. Oh, I get it. All right. In all mammals, mother's milk, you know what I mean by a mammal?
Yeah.
There are mammary glands that the offspring use for a source of food. In all mammals, there are protein substances that are used to protect the baby from certain infections. But the proteins in the baby's tummy and your tummy and my tummy will be unfolded, or the proper term is denatured, by the hydrochloric acid. And proteins, there's a whole big bunch of lectures behind this, proteins are able to do a certain job because of their shape. And proteins are a long chain when our bodies make them or plants make them, and the chain is folded up into a certain shape. But if that shape gets exposed to hydrochloric acid, it's unraveled and no longer has its shape, therefore can no longer do its what? Whatever job it was. Are you all with me on that? So the Creator, of course, understood this, and the Creator covers in the mammary gland, it covers that protein that the breasts make. They make the proteins themselves, and they cover it with fat. And then that protein in the baby's stomach does not get denatured. Pretty cool, huh? Then that protein gets into the baby's small intestine, where an alkaline condition will also denature or unravel it, but because of that, it doesn't. So that little molecule covered with fat gets actually absorbed into a cell somewhere or in the bloodstream itself, depending on the function, and confers on the baby immunity to some pathogen. Got it? Pretty cool, wouldn't you say? So this physician, scientist, oh, by the way, just for fun, guess. What else do you suppose would denature protein? Huh? Possibly, I don't know. Ah, hot, not cold. I'll give you an example. When you fry an egg, or maybe I should say when you used to, you know eggs are not good for you. You know that, right? I got to be careful not to get sidetracked. I don't know why we call it egg white. It's really egg clear. But when you fry the egg clear becomes gelatinous because the protein in it was denatured by the heat. It becomes gelatinous and opaque. Are y'all with me? Just an example. Heat denatures proteins. Now, remember, the proteins in mother's milk, we call them immunoglobulins. You know that term probably. That's the protein, and they come various kinds because there's different pathogens out there that the body is prepared to deal with. When they get heated, even though they're covered with fat, they will denature. So this scientist measured how much of the immunoglobulins were denatured if you heat the milk in a pot over a flame, or if you put that bottle in the microwave. Here's the microwave. And he found out, don't hold me to these exact figures, about 35% of the immunoglobulins were denatured by heating the milk in a little pot of water. You all know what I'm talking about? And about, I think it was pretty close to I'm going to say 85% were denatured in the microwave. And the average person who hears that will be inclined, perhaps, to conclude that those microwaves are really bad. No. I wish you could be driving across Lake Washington on the concrete bridge someday when the wind is blowing from the south. Anybody ever driven across the concrete bridges? The floating bridge, thank you, dear. And nobody else would even think of this except some nutty physicist. But when we drive by there, I point to Neva and I said, see that? What happens is, as the wave comes in and hits the bridge, an exact wave, just like it, leaves the bridge, out of phase, 1/2 wavelength. So now there is a place where the waves cancel each other and the water is smooth. Even though a wave's coming in, the water's smooth right there. But right next to it is a place where the wave is twice as high, as if there was no reflection. You didn't follow that, did you? In my classroom, I used to have a long slinky, about 20 feet long, hanging from a pipe up there so I could make waves on it. You know what a slinky is. And I would get a student at the other end to hold the slinky steady, and I would send waves down there, and they could see the wave traveling, and suddenly when the wave was reflecting, if I kept doing it at the same frequency, there would be places on the slinky that don't move at all, and between those is a wave twice as high as the wave I'm sending. They call that the standing wave ratio. I'm sorry, this is engineering stuff. The point is that inside the microwave, because there's a wave generator in there, y'all with me on this, there's an electromagnetic wave generator. It's not in the visible spectrum, it's way to the left of the visible spectrum. Are y'all with me on that? Way less energy, except for intensity. You understand do you understand why people have no clue what I'm talking about? Because all these things I've mentioned to you, they don't even thought about them. We make microwaves with enough intensity to heat stuff. But because the walls of the microwave, got to get the right end of this, reflect back and forth. Here's the generator, let's say, what reflects back and forth in here. There is a standing wave pattern in here. Are y'all with me on that? So you know this. There are spots in the microwave that are hotter than other spots. How do they counteract that in the average microwave? The turning table. You maybe didn't know before why they have a turning table, but that's because there's standing waves in there. And so obviously, there's going to be more denaturing because of the hot spots in there. It's not because there's some mysterious bad thing about the microwave. Are y'all with me on this idea? And the other day, Neva got an email from a pretty intelligent person who they were sure proved all these bad things about electromagnetic radiation. And I had her read it to me. And the guy sounded like he knew something about what he was talking about, but there was so much of what he did that it was just obvious that he just didn't know. But he has credentials, and if the average person read that, it wasn't just microwave ovens he was talking about. It was 5G and all of that. It all has to do, folks, with intensity. The amount of energy absorbed from Wi-Fi is so tiny in your flesh, I don't know that you could probably detect a temperature increase with a very fine device. Y'all with me on this? And by the way, if there's a heater in the room, is there going to be a temperature increase in your body from that? Sure. So I don't have a burden for people to, if they don't want to use Wi-Fi or whatever, I'm okay. I just wish people would somehow be able to become informed without there being voices from people who really don't know what they're talking about. And by the way, if you keep going up here, listen, folks, these are much less damaging inherently than the visible spectrum. Are y'all with me on that? Unless the intensity. Can you have a light that's so bright that it would burn you? Of course. It's not because there's something mysteriously bad about those light waves, is there? It all has to do with absorption of energy. And the way to get more absorption is to make it so intense that of course it's going to get absorbed. But in general, the microwave radiations that are coming are in such low intensity, it is just not an issue.
So as far as 5G and other, if you're closer to the antenna, do you get more intensity? Can it become
It
dangerous?
depends on the nature of the antenna. You all know that a parabolic dish, if you think about this, focuses energy. That's why the microwave transmitters, which they're stopping to use them as time goes by, because fiber optic is just a couple of million times better, see. They had a dish that would focus the radiation and of course it always spreads a little bit, and so 20 miles away they got to re-power it up to another antenna, right, to send it on to the next place. So it has to do with absorption, and interestingly enough here,
Before you move on,
okay, please.
the 85% of mother's milk there, does that go over to heating up your casserole and other food?
Very good question. The answer is essentially no, because remember what was going on. Now follow this closely, folks. This is really important for the layperson to get this. We do not use any protein we eat as it is. Absolutely zero. That protein that we eat gets denatured. It gets unfolded in our stomachs. Y'all with me? It's now no longer can do whatever job it was supposed to do. And then in the small intestine, that protein gets clipped up into pieces we call what? Amino acids. Those amino acids get into the bloodstream and go to our cells. Listen carefully to this. We make ourselves all the proteins we need when and where our body needs them. We make them ourselves. It doesn't matter at all that the protein got denatured in the pan. Y'all with me on that? Because we're going to denature it here, and if the denaturation doesn't finish here, in the small intestine, the alkaline nature of the small intestine will denature it further. Got it? Either acid or alkaline will do that, not in neutral water, but either of those. So it's a non-issue that the protein got denatured, except for the immunoglobulins, which are covered with fat to protect them from both of those places. And mothers, young mothers today, you mothers are all too old for this, but young mothers today are taught not to heat, if they're not going to nurse and they're going to pump, they're told, don't heat the milk either here or here. Got it? Because you're going to denature a fair amount here. They're taught to massage it under warm running water if they're going to pump before they feed it, to limit the denaturation of the protein. So where was I at? Before you interrupted me. Here's an interesting point. It is ultraviolet B that makes vitamin D. I think you all know that just underneath your skin, the cholesterol by ultraviolet radiation is converted into vitamin D. Did you all know that? You know it now if you didn't. And there's only one wavelength that will do that. A narrow band right in the middle of B. But all of B is blocked by ozone except that one little narrow spot. Is that cool or not? You get the significance of that? Does it sound like somebody knew what they were doing? And I won't go there. But ultraviolet C is also blocked by ozone and would be very risky because of high energy and intensity. And then you go a little further and you get X-rays. We call them soft X-rays to begin with, and then hard X-rays. And you know these can be damaging because we're finally getting to the place where there's enough energy, even without maybe much intensity, there's enough energy in that signal to do damage and to mutate DNA. Everybody knows about X-rays. You want to limit them all you can. And so I hope you still love me, even though I stepped on your feet on that topic. Yeah. Anything else that you'd like to take a minute on? Want me to suggest another one?
Yeah.
Uh,
So you said Wi-Fi in a home is not gonna be a problem?
That's my opinion, yes. And you talk to any well-trained electrical engineer, any well-trained scientist knows this. It's just, we all understand what intensity is.
And so
Yeah.
wearing your cell phone in your pocket is not gonna cause cancer someday?
Very, very unlikely. There have been many studies already. Some of the studies show that there's more brain cancer. Some of the studies show that there's less. What does that tell you when that kind of thing happens?
Something else.
Yeah, yeah.
She wants to know what about cracked screens on your phone.
Yeah, not an issue. Now, it's amazing stuff, the crazy, folks, the stuff that's out there. Have you ever seen this email where these 4 kids are sitting around a table, kind of like in their 20s maybe, late teens, and they put their cell phones down, so there's a pattern across, and the space in between them is there, and they turn their phones on, and pretty quick they crack an egg, and they drop it in that space. Can you picture what I'm talking about? And the egg starts to fry. The average layperson looks at that and says, that proves it. Come on. There's a Bunsen burner under the table right there, or something. I heard a guy that sounded credible. In fact, it's the same thing that Neva read, and all the way through I'm thinking, oh, now wait a minute. But of course, she's just reading what he said. But he really threw the pot in when he said, of course, everybody knows that when you microwave water and use it to water plants, it kills the plants. And about 10 years ago, 11 years ago, Neva came to me. I had seen that, and I said to myself, that's just such bunk. But now, I'm always open to some research. Don't misunderstand me. I'm clear on that. I spent half of my time in college, my last two years, doing a research project in physics. I'm for research. But anyway, she showed me that email, and I said, well, sweetheart, you know what my opinion is, but why don't you test it? And she took up the challenge. I've got the pictures on my computer just the other day. I'm not going to waste your time looking for them. Do you ever have stuff on your computer that you can't find when you want it? But I said, now listen, sweetheart. You got to think about this. If you're going to heat the water in a microwave and use it, then you better heat the water somehow else and use it. A, and B, you better think about the temperature. I could pour scalding water on a plant and kill anything. Right? Now, she's been around a scientist for so many years that she thinks this stuff up herself sometimes. She did the experiment, and I probably should let her tell you, but she has said many times, if anything, the microwaved plants did better than the others. And the other day I happened to bump into the pictures, dear, and it's true. I think it's a fluke, but the plants that she watered with the microwave water grew a little higher than the others. Now listen, are there any other variables in this thing? What would they be? She put them on the sill in front of the sunlight. What variables might there be?
The amount of sun.
How about the angle of the sun on one in comparison to the other? Is there a slight difference there? Sure. The average person has no concept of thinking of that kind of stuff. And they just take this hook line. And this guy, I mean, I was concerned about several things he said, but when he said that, I felt like, turn that thing off, or she was reading it. If he is that ignorant that he believes, he said, everybody knows. Anyway, forgive me for being so stoic or whatever it is.
That's why Gentry got defensive.
It could be.
Yeah.
The guy was a terrific scientist.
And when you really know something,
Yeah.
you know that you studied it,
Yeah.
and you know the others haven't,
Yeah.
and they're the ones acting naughty to you.
And their questions were not of the sort that I want to learn.
Yeah, right. They were trying to trip him up,
Maybe.
so to speak.
I don't want to judge their motive, but I was sitting there and I felt bad about the way they were treating him.
Yeah.
So, yeah. Here and then there.
Based on your knowledge of 30, 40 years as a physicist, and your knowledge of healing and food, is it possible to reverse cancer by
By anything. It's a good question, and I'd love to go on for hours. But let me make a couple of broad statements, and some of you may not like this, and I love you anyway. There are a lot of modalities out there that we do not use in our 6-day program. I don't know if you know this. For almost 50 years, Neve and I have been doing 6-day lifestyle programs. In the beginning, they were just for smokers, but in the last 20 years and more, we hardly ever had smokers, and it's just for people. There are all kinds of things that can be of some help, but what makes people well, I'm not touching cancer at the moment entirely. What makes people well is putting them on a whole plant regimen. Now they need to be active, and activity is important, but the big issue, folks, we have people come to our program, a pastor came there about a year or two ago, whatever it was. We knew him from the years I worked in the Washington Conference. And he had a fasting blood sugar around 300. His systolic pressure was close to 200. He was a walking time bomb. He had neuropathy. He could not feel anything from his knees on down. And so people come to our place on Sunday. We feed them a light meal Sunday evening, and I do 3 lectures a day, and we take them walking. Please don't misunderstand this. There's a number of areas that we don't take time to emphasize. It's not that they're not useful. My concern is, in the Adventist world, people will pick an area, and the average layperson doesn't understand that that is helpful, but it's not the big issue. And anyway, this fella came in on Monday. No, he came Sunday, but he came in Tuesday morning into the classroom, and he said, with this inflection of question, he said to me, "My neuropathy's getting better?" By Friday morning, he came, or was it Thursday? I think it was Thursday afternoon. He came into the classroom and he said, "Listen to this, folks. My neuropathy is completely gone." His blood pressure and his blood sugar, really, his blood pressure and his blood sugar were normal without medication in about 4.5 days. Now, I was a guest lecturer with the Weimar physicians for 15 years. I was the only non-physician. There was a lady that was a nutritionist that once in a while, but anyway. And Weimar conducted an off-campus 3-day, they called it 3-day, it was 48 hours, so it was really 2 days, but they called it a 3-day because it was parts of 3 days. They conducted a 3-day reversing diabetes seminar every month, somewhere in this country in a Christian conference center for 15 years. A huge undertaking. And there was about 30 of us who were volunteer speakers on that circuit, and I did that the whole time. So I've had tremendous exposure to physicians through the years from Weimar. What I'm telling you is what they teach. But it is the whole plant regimen. And one thing most people have no idea. In fact, we don't even use the V words because you can be a junk food vegan. I mean, after all, potato chips and French fries are vegan, aren't they? The thing that most Adventists miss about a whole plant regimen is the oils. All of the plant oils, when refined and taken out of the plant, become toxic. And some of them, well, I shouldn't say some, those toxic substances are carcinogens. And cancer is wreaking havoc among Adventists. Now, that cancer comes from, I told you earlier, inherited DNA problems, but there's no question about the fact that these oils need to be left in the food and not taken out and exposed to oxygen. Anytime you take oil out of a plant, any kind of oil, even olive oil, it immediately starts oxidizing. And if you put it in a frying pan, it is now oxidizing at 2 million times the rate of oxidizing in the free air. It's insane what Adventists do not know that, are doing their best. They just have not been taught. We learned this, dear, 53 years ago from the guy who taught the Weimar physicians about this. And they have taught it essentially ever since. Anyway, where was I going with that? Oh, so, yeah, the answer to cancer is a challenging one. A number of cancers have been studied, and it's probably the case with almost all cancers. When you put people on a whole plant regimen, the cancer grows slowly, more slowly. I was diagnosed with prostate cancer 22 years ago. You say, why? Well, I was raised on a ranch, folks. We had T-bone steaks cooked over the coals every night. I mean, that's just insanity. But anyway, I had a prostatectomy, and listen to this carefully. They got it all. I could quote you the pathology report, but they got it all. Why did the urologist tell me a few weeks later, when I was kind of recovered and back to see him, why did he say to me when I asked him what my prognosis was, why did he say you have 5 years? Because there is almost, I'm sorry for this information, there is almost never an exception. By the time the tumor is big enough to be imaged, not much bigger than the dot at the end of a sentence, or palpated, a little larger, maybe almost as big as a pencil, the cells have always gotten away, friends. He knew that. What he didn't know, and my current urologist in Spokane, I have such respect for this guy. He's very well informed. So I'm 22 years downstream, right? And there's cancer growing in my body. It is growing so slow. My urologist in Spokane, he says, Jim, I am not worried about you in the least. You are never going to die of metastases from prostate cancer. You know what he means by that? Stuff growing in other places or wherever. So the biggest issue, I think, for people with cancer is to immediately go on a whole plant regimen, and these oils will accelerate the growth of these cancers because of the oxidization. Those oxidized products are inflammatory, and you know today, folks, the big issue about all these diseases is inflammation, don't you? So, so don't misunderstand what I'm about to say. We don't do hydrotherapy. We don't do herbs. We don't do some of these other modalities that I'm worried that people make a big issue out of this. The biggest issue, folks, is what? Whole plant. Whole food is okay. Whole plant regimen. It's not that we don't believe in them. It's a mom and pop deal. And we, yeah. But, and these precious young people that become medical missionary workers, their big thing is hydrotherapy. And they know something about the dietary issues, but folks, the dietary issues is what makes the huge, huge difference. So I'm okay with all these other things, but what happens is you go to one of these conferences and they talk about what, and I know one's going to be herbs, don't misunderstand me. When people leave that conference, what do you think their impression is? This is a great big issue. And it really isn't, folks. The big issue, say it again, is whole plant regimen.
As compared to partial plant?
Yes. You know what the number one risk factor for cancer is today? It's just been published about 2 years now in the International Association. I'm sorry, that's alcohol, but it's in the literature. It's overweight. How many of us at Adventists are overweight? That is the number one risk factor, friends. Number one. The other thing that Adventists, this is not much of a problem, but International Association of Research on Alcohol, this is multi-country, every single drink with alcohol in it increases the risk for cancer. What's going on in America today, friends? So Somebody was saying, well, I heard that ivermectin, in fact, he's not here right now. I don't know. We used ivermectin when we decided not to get vaccinated, and we think it helped us. We eventually caught it from one of our daughters when we were in the same room for a few days. I'm interested in research. Are y'all with me? And we don't have good research on ivermectin if you want. It's anecdotal. Is sometimes anecdotal information helpful? Of course it is. Most research gets going because of some anecdotal thing that showed up somewhere. Well, let's test that, see. So, as far as reversing cancer, we don't know of anything that will actually do that. There's a man in Sandpoint. You know what's the little town just south of the bridge? Eagle? Sago. He and his wife were Christian people from there. They came to our program. He had, 2 forms of cancer and in several places in his body, and he was really struggling. He's a hunter. We've been to their home several times. He's got trophies everywhere, all over the place, in the garage, in the house. And he shows pictures of catching 300-pound bass. And they went home, folks, and after 6 days with us, and cleaned out all of that stuff, all of the meat. And his cancer just about stopped growing. But after several years, he did finally here recently pass away, which broke our hearts. Dear, older than us a little, maybe, about the same age. Yeah, maybe the same age. A precious Christian man. You go to his home and his Bible is open on the living room table, and I'm sorry, dear?
I'm not sure if she's asking about salmon being a fatty oxidant.
Oh, yeah, you guys don't have time for this. I'm going to give you a very short course. There's only 3 omega fatty acids in plants, or that our bodies use, I should say. One of them is abundant in plants. It's ALA, or alpha-linolenic fatty acid. There's the other 2, and that fatty acid is 18 carbons long. The other 2 are EPA, 20 carbons long, and DHA, 22 carbons long. EPA and DHA are not found in plants. They are found in some sea creatures, and some people will tell you they're found in seaweed only because they accidentally got attached there because they were floating in the water. Seaweed does not make it. Y'all with me on that? Our bodies, and so people tell you, well, you got to eat salmon or something like that to have good health. And it is false, because our own bodies can take an 18 carbon chain fatty acid, omega-3 fatty acid, and attach another 2 or another 4 and make the EPA and the DHA that we need. Got that? Now, it's not a real efficient process. Women do it a little better than men, but it's enough for us to have the other 2 omega-3 fatty acids that are found in are not found in plants at all. So, yes.
I had a question about Bluetooth and ear pods, and is that
Same thing. It's all these electromagnetic frequencies. And
what frequency?
the EMF, the electromagnetic waves, all of that stuff is EMF. And it's not intense. I wonder if enough research is done for long enough that just all this exposure might add up to some problems. But we've been under this influence for a long time now. And you see increases in cancer, but the research shows that the increase in cancers are the result of obesity and diet. It's hard to link them to these things. So I think it's not a bad idea to minimize this stuff. You don't see me walking around with earbuds. I have a pair sometimes that when we're driving and it's noisy, and if her cell phone won't play over the radio in our car, then we'll put one in so we can listen to somebody giving a sermon or something. But Um, listen, 100 times bigger is whole plant regimen. The body does an awfully good job of taking care of problems, but it's got to be under the whole plant regimen. And you talk about an antioxidant. All of these fats that people eat are oxidized, and they're just terrible for us. And so,
Why is oxidizing a bad?
oh, oxidizing technically means that the whatever it is, organism or molecule, steals an electron. And oxygen does that real well when it's by itself. Now, when oxygen is in the air as a diatomic molecule, it doesn't do that. But when it's in a chemical and this oxygen is there, it can steal an electron. Whenever you steal an electron, you change the nature of the substance, even though it's still the same element. The electron cloud around it, it's still uranium, or it's still hydrogen, or it's still whatever. But when you take the electron away, that atom, or the molecule it's hooked to, becomes toxic in various ways.
Heat is the
Heat's not a main issue there. It's just a molecular toxicity. That oxidized agent can now oxidize something else. And somewhere along the line, there's going to be an atom that shouldn't have had that happen to it, and it's going to be a contributor in some way to some problem. So, and oxidization causes inflammation, and you all know about this, folks. Do you know that 99% of heart attacks do not occur because the plaque filled the artery? Only 1% of heart attacks kill because the plaque filled the artery. All the rest of them occur because the plaque, the soft plaque, broke through the intima, the wall of the artery, and a clot forms almost instantly, and that happens because of inflammation. It happens because of other factors, but it would never happen if the lining wasn't inflamed. I shouldn't say it never would. The inflammation is a huge issue, and these oils are just designed to cause inflammation because they're oxidizing. As soon as you take that oil out of the plant, you have a walnut sitting on the shelf. By the way, oxidization, you can tell it by the taste of the walnut. What do we call it? Rancid. So rancidity, that taste is the result of the oxidization of the fat, or we would say the fatty acid, which is the piece of the fat that gets oxidized. And the plants do a very good job of protecting themselves. You take that nut out of the walnut, and it'll get rancid way, 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 way quicker than if you leave it inside the shell. But even inside the shell. So we tell people, when you buy nuts, we put them all in the freezer, except a small amount that we keep in the fridge. We never let the nuts just sit out in the warm room longer than just the meal, and then they go back into the refrigerator. Because, I'd love to talk about this, but I gotta quit. Because anytime you increase the temperature, you increase oxidization if it's taking place. So the freezer or the fridge is the best place for all those nuts that you love and are healthy for you, you know. So I'd love to keep going, but you'll have to come to our place for 6 days to really get the whole story.
Where's your place at?
It's called The Ridge. We're just outside of Kettle Falls or Colville a little ways, over by the lake. So, yeah, we have a website, and you can get it by just Googling Neva's name or Googling our cookbook name and Neva Brackett. You get about 20,000 hits if you put Neva Brackett in there. Oh, $7.45 for the week. There's a $50 discount if you register early. And you know the other places all charge close to $1,000 a day. So it sounds like a lot of money to me, but and I think if you talk to anybody that's been to our program, they'll tell you they've really, really loved it. And especially Neva's cooking. Neva is without a peer. That girl is something else. And so I wasn't going to advertise that at all. Anyway, it's been fun.
Thank you.
I could go on forever, I'm sorry to say, but you could just follow the book.
Yeah, one more question. You mentioned eggs are bad for you. Can you tell us about that?
Yeah, because they're high in fat They have this much fiber. They're high in protein. You might not know this, folks. High protein diets are bad for us. It's crazy, but it's true. And Americans have no clue. No clue. High protein diets increase cancer measurably.
Oh, they should watch that. Eating You Alive. What's it called?
I'll put it on the board. This is what it's. You all know about Forks Over Knives. Eating You Alive is 10 times as useful. It's just so outstanding. You can buy it for $10, or watch it on YouTube once for $2, $2.95 or something. For $10, you pay YouTube $10, and you can watch it anytime you want, as many times. And it's Eating You Alive. Just absolutely outstanding. Huh.
Yeah, she just mentioned, I know all this, I just can't
Do it.
do I just can't overcome the temptations. That's.
Yeah. Amen. And at our program, every day we have a voluntary time for spiritual looks at things. There's no question, folks, it's tough. I shouldn't even tell you this because you'll never come then. But people pay $6,500 to go to Weimar for 18 days. And when Neil Nedley first became the president of Weimar, he asked me to come and be the administrator. I was busy building cottages for our program, but I went for 2 years. He had to close his practice before he could get to the campus. So I was the boss there for 2 years. And I went to every single graduation. I went to almost every time a new group came in and they would meet. And the VP would speak to them briefly, and I would speak to them at the graduation 2.5 weeks later. And they're well. They know why they got well. They are going to go home and do this. It's beautiful. That you would be thrilled to hear them talk. But over the long haul, only 1 out of 10 stay on the program. And there's all kinds of reasons. I think if they would use Neva's cookbook, the food folks, and Neva doesn't even like me to do this, but God has blessed that girl. A lot of people's healthy food tastes pretty bad. Have you ever noticed? But God has blessed her. You talk to anybody that has ever eaten at her table, they will rave about it. And we have done, since I retired, we have done 53 6-day programs on our property. That's a lot of people. Average number, 8, 10, sometimes larger, sometimes smaller groups. They will all tell you the food is fabulous. But you have to follow the recipe. There are some people that will look at it, oh, I know what to do, and it doesn't turn out too well because they didn't follow it carefully. Especially when you make the granola. I'd love to tell you more stories, but I'm going to quit. But anyway, it's a spiritual battle. There's no question. And I have a spiritual battle. I have faults, folks. I told you, didn't I? The other day I was unkind to the pastor's mother-in-law. Didn't I tell you that? What in the world is wrong with you? But I think if you determine to do it, and you determine to let self be dead, that's a tough one, folks. Let me ask you a question. Have you ever had your feelings hurt? Say yes. If self was dead, would your feelings be hurt?
For a shorter period of time.
0 period of time. And I'm a big offender, folks. Well, by God's grace, I have learned. But there was a time in my life I could have my feelings hurt pretty easily. The problem is self is alive. You know what? One more story. One day, there appeared in my mailbox at the church a book, anonymously. The title I was the head elder at the time. The title of the book was The Power of Humility. What to do when you know you're right. And my dear friend, help me say the author's name, dear. Leroy Moore. Leroy. He likes to be, he's gone now, but he likes to be called Leroy. Leroy Moore. Just a wonderful man. We got to know him very well. Leroy Moore. He's written about 5 books available in the ABCs or online. Wonderful, wonderful man. Was the author of the book, and he used 1888. I think all of you Adventists know about that. To illustrate, and here's his proposition. If both sides would have humbled themselves, the Lord would have led them to the place the Lord wanted them to be. And there would have been no conflict. The problem was pride. And I didn't read the book right away. I wasn't offended, although I thought, boy, if there's somebody in this church that sees pride in me, Lord, I don't want that. I want to get rid of it. The lady that put it in my box eventually confessed to me. She's a dear friend, actually. I love the book. It was beautiful. You can tell from just what I've described, right? And I've shared that book with lots of pastors and elders here and there because, folks, you know this. If you and I want victory, self has to be dead. And you make that happen simply by choosing. Not just the words. You actually choose. You usually say to God, I usually say to him, I want your way, Lord. I want your way. And I'm happy to have self be dead. That's just fine. And it's pretty nice, folks, when self is dead and somebody makes fun of you or abuses you in some manner. You know what? It doesn't matter. Because what? Self is dead. Let's pray. Father, we long, Lord, to follow your plan for our lives. Thank you so much for your love, for your mercy. Bless this congregation that they could be more and more of a blessing to the community. I pray in Jesus' name. Amen. My knee is burning again, dear. I need some ice. Sweetheart, would you try to find those balls that went into the pews somewhere? You know, I broke my leg a week ago yesterday. But the biggest problem was my whole leg just got chewed up like it went through it. And so it hurts sometimes. Well, there's 2 there, dear. It's hard for me right now with my knee hurting to get down and get pick them up.